Hey everyone, thanks for joining. I'm Sally Ann. I work on the product team alongside Aparna. You want to give a little intro?
Yeah. Hey, everyone. My name is Parna. I'm one of the founders here to Rise and work on the product side as well. So this is a timely topic because me and Sally think about evaluations all the time. So let's jump in, Sally.
Let's do it. Yeah, so for today's paper, we're reading a paper called Who Validates the Validators. It's basically a paper that puts forth a framework to align like LLM assisted evals with user criteria. So let's get into it a little bit. Oh, before we do, something very important. We are hosting an event in July 11th in person in San Francisco. You can use this little QR code here or that promo code that's at the bottom to get a little bit of I think it's $200 off the ticket price. So it's going to be a really awesome event. We have some really great speakers. More information will be coming, but definitely use that promo code to grab your tickets.
It's going to be awesome. We have an amazing, amazing lineup of speakers joining us. So folks from Mistral, folks from, we have researchers, developers, open source community. So check it out.
Yeah, it's gonna be. I'm super excited. So. But yeah, so in this paper, the team puts forward this open source tool called EvalGen, and they do this with a few different motivations. So thinking about like current eval frameworks, we know that this um, LLM assisted evals are kind of required. These automated patterns are required to actually get performance on your LLM application, just because the sheer volume of queries that exists, the time it takes to kind of read through all of them and manually judge them, it just takes a lot of time. So it really requires that we use these LLM judges. But something that this team calls out is that there can be a lack of transparency or assistance in actually aligning your goals with these evals. So that's really the main piece that they aim to fix with their EvalGen framework. So on the right here, we have the actual framework of what usually exists when you're talking LLM assisted eval. So we have our inputs. It's going to an LLM with some kind of prompt. So something like, I want you to do X, Y, and Z. We get our outputs, and then we're going to go to our evaluator column. So this is where we have some kind of prompt, like I want you to evaluate my responses for correctness. I want you to evaluate them for being verbose, whatever it is. And you can also have like coded evals, which I think is important. And then you get your test result. So this is what like the current framework is, or the typical framework. And we'll get into a little bit more about the evals, but the goals here, so develop a evaluator for grading LLM outputs, but validate the quality of these evaluators through alignment of user preferences. So that second one's the real key point there. Anything you want to add here, Aparna, on this?
Yeah. So first off, actually, I realized we didn't mention the paper authors. So this is an awesome paper come out of UC Berkeley. Shreya Shankar, folks follower. She's actually super um, uh, she tweets a lot about content, really good content about the space. So Shreya Shankar's the author of this paper, came out of UC Berkeley, so go Bears. And I guess maybe just a quick zoom out of
Sure.
why this paper matters. So people are building LLM applications. We work with a ton of folks who are doing this. I think what people are trying to do is, how do I actually evaluate the outputs of these? So in the image that you see there, there's all the inputs, which could be the context, the retrieved documents, whatever it is. They have the prompt, and then they have the LLM output itself. There's kind of been a path, and this is really more common. You see it on the ML side, where there's these common coded metrics. So think about like the AUCs, PRAUCs, like typically common standardized metrics. People will code them. It's deterministic. And that's one category of metrics. And I think in the beginning, people were trying to use them for things like summarization tasks. Can I use the blue score? Can I use the rouge score? And so those are standardized type of metrics. But what's really become, and we see it across all the folks we're working with, is there's another paradigm, which is called LLM as a judge, that is becoming really popular. It is probably the most popular technique we're seeing out in the ecosystem. And the reason for it is, well, first off, if you have evaluation tasks that, if you're doing anything other than honestly, even summarization, and you don't have a ground truth, you're not going to be able to use those coded metrics.
Yeah.
And those metrics do depend on having some type of ground truth versus with the other approach, which is kind of the path. Let me see if I can annotate the screen here. Okay, I can't, but it's just the metric prompt and the evaluator prompt over here. Yeah, thanks, Sally. Basically what it is, it's a little meta. It's using AI to evaluate AI, but you're basically passing the output over to another LLM call, and you're giving it an eval template, what they're calling metric prompt, and you're asking an LLM to evaluate how good was the response, did it meet XYZ criterias, which we'll get into. And yes, it's using an LLM, so it's using, some people are skeptical of, is it good enough? Is it doing what it's supposed to be doing? But to be honest, the reason it's getting so popular is because you don't need a human, you don't need ground truth. It's way faster, it's way cheaper. And so if you can find some way to test and validate on some data set that it works 80, 90% effectively, you just have this much cheaper, much faster approach to getting back evaluations for your model. So it is becoming a very, very common practice to do it this way. But as Sally's mentioning, it's pretty hard because people don't know how good these metric prompts are, how good the eval prompts are. How do you know, and this goes back to the title, who validates the validator? How do you know if it could be better? How do you know if it could be improved? And so that's kind of what this paper is starting to break down is, let's evaluate our evaluators.
Yeah, it's really like taking it to the next step. Like we've kind of proven out that like, okay, the LLM as a judge, best way to kind of evaluate, but I think there are some gaps, especially depending on which tooling you're using. And so this just builds on that, and we can kind of go talk about that a little bit more. So this is their workflow here. This is if you were to use their tool, kind of the flow that you would go to. And so the first thing you do is it's part of chain forward. You would access this multi-eval node, and then through the interface, there's a few different options for setting your criteria. And I think this is something that's super interesting about what they're proposing here. And so it's three options that you can do. You can start by inferring. So this is where they're actually using an LLM and AI, however you want to think about it, to generate the criteria. So it's kind of looking at the data, looking at the responses, the inputs, and deciding what would make sense to use as criteria. The second one's probably what a lot of people are more familiar with, and that's when the user themselves are manually selecting the criteria. So it's like, I want to look at the format. I want to look at the verboseness of the response, the correctness, things like that. And then there's a third option, which is grading. And this is just kind of, you can think of this as user feedback of like good or bad, just a kind of a simple label that you can start there to evaluate the responses. Yeah, Aparna, anything to add on those?
Yeah, so this is actually the like three big, I guess, like paths here. It's like, okay,
Mhm.
either the tool itself can come up with this criteria, which is amazing,
Yeah,
right? Because
super
then
cool.
you don't have to think about, okay, so I have this type of summarization task. Here's maybe
Mhm.
common criteria. Is it concise? We see that a lot of people are asking that. If you're generating some type of response, is the tone what you'd
Mhm.
expect it to be? Is the tone consistent across the responses? So I think the inferring criteria, I think makes a ton of sense based off of like super valuable because you're
Yeah.
suggesting what they should care about. But of
Mhm.
course, then there's this, for my specific application, a generic criteria might not just cut it. And so
Yeah.
there's this iterative workflow of which I think we were talking about, we really liked of like,
Mhm.
uh, how do I as a user, if I specifically, I don't mind if it's verbose. I actually don't care about it being this. I actually more care about it being accurate. So how do I go in and like
Mhm.
specify that criteria myself manually? And then some people will prefer the other, which is maybe they start with the other approach, which is let me start building a golden data set. And
Mhm.
I don't know what my criteria is. I don't know if a
Yeah.
response is good or bad until I go through the exercise of actually grading them myself. And so you kind of see the like section D, maybe you can hover over it, where in this
Yeah.
flow, someone's actually like doing the thumbs up, doing the thumbs down, and that's their way of figuring out, okay, well, how did I figure out that that was good and that was bad?
Yeah.
And so they're figuring out that criteria in this process of doing a couple grading.
Yeah, it's kind of like I definitely, and we'll get into more into this. It's definitely like a cyclic flow. But I think you explained it really well. It's kind of like the first and last options here are kind of like unopinionated flows. Like maybe you don't know what to do, or you need to build that golden set. And then this middle ones is more when a user has like an opinion of like, okay, I actually only care about it being correct. That's all I care about. And so they can go in and do that. So yeah, so these are the three options. You get the criteria. This is where you can kind of adjust. Then you would view the actual prompt, the results from the criteria, and then you can do a good and bad, thumbs up, thumbs down, and that actually gets used. And we'll talk about that in a little bit more detail. But high level, this is the EvalGen
Work.
workflow here.
And I think you can see
Yeah.
straight from the beginning of that workflow, they're starting with like, this is not a one and done type of thing. This
Mm-hmm.
is a, and I think we feel this too, Sally, as we're building
Yeah.
out for different customer use cases or our own use cases.
Mm-hmm.
You don't just ever come up with one template and then you feel like it's done.
Yeah.
You go back to that golden data set. So I think this was really nice just to see that there's different flows.
Yeah, totally. I agree. It's all iterative. Like every part of these LLM pipelines is just a very iterative process here. So I guess we could talk about the pipeline here. So on the first slide, we showed you what the pipeline is for kind of current LLM evaluators. This is EvalGen evaluation pipeline. And so something I thought was really interesting about this paper was the fact that they break down the evaluations into this concept of criteria and assertions. So I really love this idea. And so what a criteria is like that first layer of what you're looking to evaluate the LM response on. So in this example here, we want to understand if the responses are polite or not. And then they add this second piece, like the criteria is very like what's in the traditional flows, but this assertion is what's kind of new, which is the actual guidelines to assess the criteria, which I really liked. So you can see here that they're calling out specifically words like please, thank you, and sorry indicate politeness. So that's something new, and you can kind of see it in this flow. Here's the same as the flow we showed you before, but this green box is going to be the EvalGen, and you can see here that they get the candidate criteria, but then with an LLM they actually get these assertions as well. So it's really cool to see that. I like that idea of law of giving it a little bit more guidelines. Something about LLMs that we know is they're non-deterministic. So when you give it a little bit of extra guideline, it kind of increases the chances of you getting a reliable result. So I like that a lot. So the LLM here, I think they use GPT-4 exclusively in this paper, but you could substitute this for any LLM theoretically. It's going to suggest that criteria. It generates multiple candidate assertions for each criterion, which I think is really cool. So we're doing kind of that, the multiple iterations. It's not just one criteria or one assertion. It's multiple. And then they actually rank the assertions by comparing them to the human grade sample. So this is where you start seeing this kind of flow. Like if you look at this here, we're getting the criteria, we're getting the assertions, but there's this iterative flow here where then the user's coming in, it's grading, we're changing the criteria, and it's just kind of going through that cycle until we feel confident about the test results here.
Yeah. And
Yeah.
I think like, so you see there's kind of like the human in the loop, which is in the
Mm-hmm.
top up there where they're saying the things like we were saying, oh, is it concise? Is it polite?
Yeah.
Like I want it to be. But then if you had to get down to an actual assertion on it, so if you're going to something like, in this case, the polite has to
Yeah.
say, please, thank you, or sorry, you could still be polite without saying those things.
Mm-hmm.
And so I think there's like this balance of like, what are the assertions? How
Mm-hmm.
specific do you need to be?
Yeah.
And sometimes when you're using these LLM evaluators and you're not building those assertions itself, under the hood, it is, there's these implicit assertions that are being made. And so you might think of something, if you were going to go back and do the human grading, and you might think of something as still polite, even though if it doesn't include these words, all of these come back to how do you actually get really concrete about this concept of assertions?
Yeah.
It's really hard
Yeah.
to don't want to be too prescriptive, but you also this is the most concrete way to tell another system to to kind of replicate what a human would do.
Totally.
So I think that like as we were discussing this earlier, we were talking about well, I would love to know, and maybe we get to this in, oh, it's actually the next slide. We could get, um, like, is there a benefit of, like, how good is the LLM itself in the beginning coming up with its own, as it's inferring the criteria? How
Yeah,
good is it at coming up with those assertions?
totally.
Right? Like, is there certain types of tasks that it's generally better on? Is there
Mm-hmm.
certain types of tasks that it's not that great on? And um, how do you get that view into those assertions so that you can then know what to go fix or improve? I think is a hard challenge.
It's almost like we're applying, some level of evaluation to our evaluator, right? Like that's what this is really doing is we're taking the human, we're adding it to the loop, and we can just have a better grasp and we can iterate. And I think that's important because that's what you're really calling out. Is like, how do we know if this is like the right set or if I've done too much? And this review process really helps us to do that. One last thing I'll call out on this slide before we go to the next is another piece that I really liked is that the new assertions are checked immediately once we go through this kind of loop, and they remove any of those poorly performing ones. So it kind of makes sure that we have super high quality, super reliable results. And so that kind of constant iteration and improvement is something that I really like about this pipeline that they put forward.
So, do you remember how they check that immediately? Is that just based off of that human grading?
Yes, it's actually, we're going to touch it, I think, on the next slide. We can go there so we can see it. It's using these metrics. So they basically they rank essentially using coverage and the false failure rate. They use that combined to then rank items, and then like the top ranked ones are considered. I think want to say 10. We can go check the paper, but there's a certain ranking that they use, and that becomes kind of like their gold standard. And then, poorer performing ones are the ones that they would remove.
Got it. Got it. Got it. And let me just tackle actually Raymond's question in the chat here. So Raymond asked,
Yeah,
how would it handle sarcasm?
and
Raymond,
that's a good one.
yeah, in the previous one of, okay, maybe they weren't polite, but they just threw in the word please.
Mhm.
I don't know specifically about how this this data set, they tested on a couple different data sets. I don't know
Mhm.
specifically how that data set and their eval did on sarcasm, but it's a really good question of like, I think it just underscores the point of like two specific criteria, two specific assertions might not actually hit your criteria
Yeah.
because you want is politeness, you want to be able to catch if someone's not is being sarcastic, but just because they throw in the words please and thank you
Yeah.
in it doesn't always mean it is. And so leads us to really this question, which is more assertions always a good thing? Um, and so there's kind of a paper that they were comparing against their EvalGen framework as opposed to the SPADE framework, which was a prior work in this area. And I think the key numbers here is actually, so obviously they tested on the same data set size, they had the same number of bad outputs. The important thing here, though, is that you'll see in the EvalGen paper, there was slightly less. I think they said in most cases it was like almost half the number of
Yeah.
assertions. So this is like how specific the how specific they were in their criteria, but it still did better in terms of coverage.
Mhm.
So especially on the product pipeline workflow. So this was a specific data set and a specific workflow that they were testing. And so in that one, it did basically almost 2-ish x better, maybe,
Yeah.
compared to the previous paper without being as specific in the number of assertions. And so
Mhm.
um, I think that's kind of like the key thing here. And then alignment too, it did better. And sorry, Sally, do you want to go over the coverage and the
Yeah.
alignment again?
Yeah. So we have the definitions up here. These are the metrics that they define. In the definitions, they'll probably be more similar to some other metrics. So you have coverage, and that's like how well an assertion finds good responses. False failure rate, this is avoiding falsely marked good responses as bad. Um, And then we have alignment. So the alignment is the harmonic mean between those two metrics. So you can think of that as like balancing the accuracy and consistency there. So these are the three metrics that they're using to evaluate and compare these two methods down there.
I mean, the thing you want, and I think this is like the hard thing we struggle with as humans too, is like, I just want to like say what I want, and I want the LLM to understand
Just
specifically,
get it.
just get it. Exactly. I just want to figure it all out. And then when you start getting into all these nuances of the assertions and you're like, oh, you're defining all of this, at that point, you're getting to a spot where you're doing a lot of work to
Mhm.
refine it. And so I think the goal, my takeaway from the goal of the EvalGen workflow was like, how do we make it easy and simple enough so that people have something to get started with? But
Mhm.
then you just leave them with that and they aren't happy. And so you
Yeah.
need this like iteration and reinterpretation. And I think we do this a lot when we're building
Yeah.
vals and things for customers. We see that like, okay, maybe we were too strong and specific about one thing.
Mhm.
And because of that, there's a lot of things that could have been marked yes or good enough that we said were hallucinations or et cetera.
Mhm.
And how do you do this kind of um yeah, I think that was a really good it's a really good, I think, concept or a place to start of like, can I do as much of the work and lift that off of the user?
Totally. It's a good jumping off point. And when we get to the user feedback, you can kind of see what ends up happening when you actually go through this flow. And I think you're describing it because it's what we go through with customers all of the time, this iteration. Um, but yeah, it is really interesting to see that no, more assertions is not always a good thing. It's, I think, always a fine line with LM prompting of too much, too specific, and not specific enough. So it's interesting that same problem applies here. Um, and so they did do like a user study. That was a big part of this paper here was they had, I believe, 9 participants take part and actually use this framework that they put forth. And it was interesting. 6 started with auto-generated criteria. That makes sense to me. I mean, something we talk about with customers all the time is they want the out of the box kind of solution. And so that makes a lot of sense that majority of the folks wanted to start there. 1 participant did write their own criteria, and then 2 actually started with just the manual like labeling process too. So we had a variety of different users on their entry points of how they started interacting with them. And these were some of our key takeaways. So I think the first one is really important and something we'll kind of spend a little bit more time on is this idea of participants continually refining and reinterpreting criteria based on their observations. So what this really means here is, starting at the beginning of the flow, if say we had a user who did auto-generated, once they're going through the review process of that, they start to identify gaps, maybe in their criteria, or maybe we're being too specific. So they realize that they have to kind of continually adjust the grading approach that they're using. And so it's just like this cyclic flow of like you adjust the criteria, then you kind of observe how it's doing, and then as you're going through and you're manually updating, you find something else that either you're being too specific about or you forgot about. And so participants all like across the board realize this kind of need to iterate on it, which is really interesting and it makes sense too, right? Like as the more time you spend with it, you just kind of just naturally recognize more and more things you want to touch on. And this is kind of what you were describing, what we do with customers, right? Aparna of like, we first off say like, oh, we need to check hallucination, and maybe we do something that's too strict, and then we're like, oh, maybe that's not really a hallucination. And so this happens naturally. This framework just gives you like a good way to go about like um, just
Yeah.
being structured about it.
I think the other question we have is like, how much though? Like
Mm-hmm.
grading of output. So people ask us a lot of like, how big does the grading
Yeah.
approach is building that golden data set. So how big does that golden data set need to be? Um, if you only have a couple examples of something that is, maybe being too strict, and then you're optimizing your eval prompt based off of that, um, you just have you're over indexing on something, and they mention
Mm-hmm.
that in the paper too.
Yeah.
And so I think that like the question I would have is like, maybe back to, I don't know if to follow up on the EvalGen folks of
Mm-hmm.
how many grading approaches did they feel like they got to a spot where that alignment metric that they cared about, or the coverage metric they cared about, got really, really good
Yeah.
across different
That's a good
data
call
sets?
out.
Um, but we actually probably start, I'd say with a lot of the folks we work with, we definitely ask for this concept of a golden data set, because there's
Mhm.
nothing like a human having thought through the criteria themselves and giving it, especially for folks who are building these LLM applications, like going through and thinking about that criteria yourself instead of just like first pass relying on an LLM, I think is super helpful to know um, where your criteria actually is.
Totally. That makes a lot of sense. Um, yeah, so some of these other their takeaways here, and we can kind of get into a lot of stuff you just touched on part on our next slide. Just some other things to call out here is participants did find that like being able to customize like the metrics and just using those to align the evaluations with the expectations was super helpful, particularly for any of like the subjective or like complex criteria. There was often some misalignment between like interpretations of criteria or maybe inconsistencies to like converting, natural language versus code-based assertions. So that can kind of be expected whenever you're doing any kind of conversion there, or the subjectiveness, right? Like if you have one data or one AI engineer who set the criteria and one that's actually doing the reviewing, they might have different interpretations of what that criteria means. So there is some misalignment that happens. And something that is interesting that they definitely called out, even the participants who took part in this study, they did have some significant skepticism around LLM judges, essentially, especially in like production environments. There's still some skepticism of this is the right, reliable way to assess LLMs in production. So those are the key takeaways. Um, so we did
Mine
get a
has to,
yeah.
let me take his question right now, or their question. Is there any open source data set for evaluating LLM responses with respect to different criteria or metrics, hallucinations, relevancy, toxicity, etc.? So mine, there is, and there's actually happy to link to, so we actually have an open source evaluation library, Phoenix, where, a lot of these criterias or metrics you're talking about, we have actually built out and tested on open source data sets. And there's a lot of different ones out there. The WikiQA one, let me just pull up a couple just to, drop it in the chat for y'all to look at. There is, I think the nuance that we see is that even if you're using these open source data sets, like we mentioned, for um, they're great for helping you build out that initial, what is the eval template. But the issue is like, are those necessarily the right, does it have all of the criteria or all of the assertions that's necessary for your application? And so if in some of these data sets, their focus is not on, let's say, a specific, I don't know, they're not asking questions to consumers. They're asking
Mhm.
more about general knowledge type of information. Just the response, um, what is so things like, what does conciseness mean about general knowledge types of questions versus consumer product type of questions? What
Totally.
up information would you like, for example, with some folks who are building chatbots for recommendation engines, they want to include things like cost of the actual product or price of the thing that they're selling and location of it and what other reviewers have said. And so all of that might seem a lot for, I don't know if that qualifies as concise in some of the data sets that you'll see that are public out there, but it's totally okay. And that's actually what they want when you're giving these products in more of that like recommendation chatbot. So yes, to answer your question, and let me just drop the link of where you can see some of these evals and the data sets they're tested on. Yes, there are out there. I think they're a great first place to start.
Mhm.
It's what do you do afterward to start to incorporate those metrics back into your own application use cases, where that golden data set in your own world is super helpful.
Totally. And it's just that flow we've been talking about, right? Like you're talking about starting with the pre-tested kind of evals, and then you do some kind of maybe grading, looking at your own data set to try to make those connections, and then you're implementing, the custom kind of eval. So it's exactly the flow we're pretty much talking about.
Yeah.
Oh, we just got another good one. It's what exactly is a golden about the data set? So with that, and try to help me out with this answer too, but it's just basically you can think of it as a good or bad example of a set of examples, really. So it's kind of aligning that criteria with where you can actually test against. Like these are all really toxic responses, or these are all really good responses. Anything like that, you can kind of set the criteria, and then you just gather your examples there.
It's a data set with labels,
Yeah.
essentially. And you're using it to, so, and those labels can come from humans. And it's golden because you're using it as kind of the benchmark to then
Mhm.
evaluate how good was your eval template. So the evaluator, exactly, Raymond-based
Yeah.
truth, yeah. You're using it to basically evaluate how good was my, LLM evaluator when I asked it to evaluate these, how good was it relevant to my golden data set labels? Yeah. Okay, this one's actually a really interesting one that I think it was really only became evident as we were going through the paper. I was like, evaluation criteria can change. I don't know why this was
Yeah.
a little bit of a,
It's
being,
like that duh moment kind of like, yeah,
yeah.
criteria does change.
And I think
Um,
too of like, you'll start out and someone's like, this is, um, I want to be super strict on, uh, something like certain criteria they want to be super strict on. So is this age appropriate is one that people are really,
yeah.
really strict on, as opposed to some of the other ones, like, is it, concise enough? Is it good? Like, that's okay. But what we notice is that some of these, user might start off either super loose or super strict.
Mhm.
And then as they're actually grading the examples, there's a lot of nuance in what actually matters, and that requirement actually shifts. And so whether that's actually and the paper lays it out, there's a lot of different reasons it could happen. It could be because of requirements. You're seeing more, um, you want to get tighter on
Mhm.
controlling toxicity. You want to, the data itself. So this is kind of more of a data drift type of thing, but data from the outside world is changing. You have different people who are evaluating it. It's not always the same person. And so that criteria and what those assertions are could slowly drift over time. And
Mhm.
what that means is, what your LLM evaluations were at one point might not be matching the bar that you're looking for at another interval of time.
Yep. And so like that just kind of that causes like the inaccuracies in your evals and the misalignment. And so I think the solutions here are really important. And this again, it's what EvalGen is doing, what they're proposing here with this framework, which is that regularly updating criteria to stay relevant. It seems like that is really required. It doesn't seem like maybe, I mean, as things advance with this kind of like inferring criteria, you could maybe skip this step, but for right now, it seems like that kind of looping through and having these cycles on your criteria is really going to be important to make sure that you're always having these accurate and reliable evals in your production system. And I think collecting input, when you have these human evaluators that are maybe creating the golden data sets or judging the evals, getting their kind of thoughts and collecting that so that you can kind of put it back into your criteria. Those are all things that are going to be helpful in this process. Oops. But yeah, I agree, Aparna. When I read this, I was like, oh yeah, that makes sense. There's drifting in the criteria, things change. But I really never thought of it that way prior to reading this.
It's just interesting because I feel like in the typical ML metrics type world, where you're actually using code to generate
Mm-hmm.
things like AUC or whatever, it's not like the definition is changing. The
Right.
metric might have a drift. Your standards for what's good, and maybe that's the way to think about it, is
Mm-hmm.
that your bar for what is a good AUC and what is a bad AUC might change.
Yeah.
Um, Here, because we're actually using an LLM to do that evaluation and define that criteria, the definition itself could change. And I think that's the definition could change because it's coming out with the outputs, and then the bar for those outputs can also change. So I think that is like a slight little shift than what
Yeah.
you know, a lot of folks coming from the ML side are probably not used to.
Totally. It's like kind of a new nuance of these systems here.
Yeah.
Cool.
Uh,
We do have two questions if we want to answer those before we do that last slide there. I know we're having a fun time.
let's do it.
So the first one is, how are folks dealing with large variation of templates, like tools, template designs, etc., especially now that we're feeding LLM outputs into other LLMs? That's a really good question there. You want to take the first go at it? You want?
I think so yeah, it's a really great question, Yor. I mean, I think prompt management is just important.
Mhm.
So we see a lot of people doing this in a couple different ways. Um, the thing I'm not so a lot of this is code based. So I think people are thinking about prompts as code, especially when you have things like prompt templates where you have variables that go into the prompts. And so you are essentially building out a template for what the actual prompt will look like. You're not constructing it every time. It's slightly more on the application side, but you are doing this in eval templates, of course, as well. And so we're seeing a lot of people actually use tools like Git-backed type of
Mhm.
versioning control systems to handle prompt management. It's great if it's close to code because then you're not, you know, you don't have something in some UI thing that you have to pull the latest version. And so it's nice when it's kind of using similar best practices that we do to code of having it versioned and close to some kind of code versioning tool. So that's probably the most common thing we're seeing. And yeah, I think being able to handle, I think you need some place of maybe groupings of like, these are my app templates. These are my, you know, eval templates. These are, yeah, tools. And then even within an app, we're seeing a lot more. I think we have one of the next eval sessions workshops is on like router-based architectures that we're doing. So we're
Mhm.
seeing a lot of people break it down. So it's not just like the system's not just like one prompt, one output. A lot of this is like multiple components, and you have a router that's actually doing um, the routing to different components in the system. And so defining what those templates are that go to different components is also part of the templates you need to manage.
So
um,
it's a lot. It is
uh,
fun.
one more.
Um,
Questions have been great. What is your thoughts using LLM to validate LLM response, including selecting first criteria and then testing response on that criteria? The minimum 2+ extra LLM calls to validate the LLM response. What will be the cost of such solution, and is it scalable and usable in the industry? Okay, so let me try to first understand this question. So sounds like the ask here is first, basically using an LLM to validate the response just based off of criteria. And then you're basically validating those criterias as well. Um, uh, I don't know, is there a good example that we could maybe come up with to help grok that? So I get your point of like you kind of want to you know, you're breaking down basically the eval into like these multiple criterias, and then you're
mhm.
evaluating how it's doing on maybe each of the criterias itself. So you have like an eval, and then you have like a validation layer of
Mhm.
each of the criterias. Um, if I'm totally honest with you, I don't see this approach right now being used that much out there. And I can give you my take on just like why. I think first people are themselves trying to struggle and grok the idea of like using an LLM to do the evaluation call. And the thing that they're struggling with is like, do I need to do it on all of my data? Which we actually say, you know, sampling's pretty
Mhm.
awesome. You're trying to get a gauge of how good your application's doing. And so I think there's already this like, okay, if I'm doing, you know, if I'm spending, let's say you have, I don't know, X number of budget and you're spending 90% of it on the application LLM calls itself. I think there's already this debate of like, do you spend 10% or whatever? Like, it depends on how much you sample. Because if you do it
Yeah.
on every one, it might be too expensive. So like, how much are you actually going to sample to generate this evaluation. And now adding additional 2 extra calls to validate, I think can be tough. But the other thing we recommend that it's kind of getting to your point, but it's different. We actually recommend explanations on the evals. That actually is it's less of like valid yes or no or binary on the eval, but more of, can you explain why you came up with this response? And sometimes you can do it, in our library, you can actually, there's ways to do it in a single call, there's ways to do it in 2 calls, but you're basically, that explanation just gives you slightly more reasoning as to why it came up. Let's say it said hallucinated. Oh, it hallucinated because it didn't use the information within the reference text. So like that explanation is super helpful. And you could call that maybe another way of validating the response, the eval response.
Yeah, I think it is helpful with that criteria, right? Because a lot of the times when it's generating that explanation, it's using the criteria that was set for it. So you can kind of see maybe where you need to loosen that or maybe add something. Maybe it's not catching what you want it to. So I think that is a way that you can streamline the process and still get after what you're asking there.
Yeah. Man, I'm just gonna drop a evals with explanations doc here for you. It kind of explains kind of when it can be useful.
Yeah, I guess there was one comment about the additional latency in the application. A lot of times it's a slight increase, but a lot of times you can do it like, post hoc too. So you can kind of remove the latency from that in the app of like when you're having a user interact with it and kind of do it post hoc so that you can get the explanations in the evals still. So that would be one hint that I would share. But they are generally pretty fast, and so the latency is pretty minimal. Does depend on a few different factors, but that's one thing I'd call out in regards to latency.
Yeah, I think decoupling it, so you're not doing it at the same time as the application is what we commonly see. A lot of people do.
Totally. Absolutely. Awesome. We got just 2 minutes, so you can just do these last takeaways for all you LLM app builders. So even though there is some skepticism around LLMs as a judge, we do believe it's the strongest path for evaluation. We're seeing a lot of folks get a ton of value from using LLM as a judge to evaluate their LLM systems. We talked about this a few times in this talk here, but figuring out what that criteria is tends to be the hardest part. It also, we have to kind of really define what the best insight's going to be on where to approve. So it takes some time to kind of develop those insights and an understanding of what you mean. So that's definitely the trickiest part. It's an iterative process building that criteria. So we talk a lot about that during this paper reading of needing to set up the initial criteria, have the LLM judge your responses, and then go ahead and actually grade those yourself and build up your golden data set. So this combination of tools, the inferring, the adjusting, the grading, all of that is really what's going to help you build the strongest evals. Some questions Aparna and I still have, maybe for our own research or for me for the paper researchers, is just like, is there a world where just inferring criteria is possible? We'd love to understand better what the gaps in the user study were, like what we talked about, like how many rounds did they need to actually get to a good spot? Were they happy with the inferred criteria? Did they find themselves adjusting it? We have some kind of open questions around that. And then one thing that the paper said that Aparna and I also are firm believers in is just having that control and transparency around the eval criteria is really going to be crucial for yielding reliable and valuable results. So as Aparna mentioned with like the pre-built evals, it's a really good starting place. But when you start having control and you can kind of really dictate what that criteria is going to be to eval, that's where you're really going to get your good results and be able to take actionable improvements. Anything to add, Aparna?
I think if you got anything from this paper talk, it's iterative. I think that's the is to play, and I think we're going to see a lot more workflows like this on how to validate and do it. So thank you everyone so much for joining, and yeah, hopefully you had a good time going through this paper with us.
Amazing. Thanks everyone.
Yep.